Okay, so I just wanted to kind of go to one of your homeworks to see what you might be doing with that p-value. And what you're getting right here is not the same thing I'm getting off of my Excel. So what I wanted to do was show you what I'm doing in Excel to make sure you're doing exactly the same thing. So you got this test statistic of 2.704. And we have the size of our sample is 15, which means our degrees of freedom is one less than that, 14. So 2.704 with 14 degrees of freedom equal norm, I'm sorry, not norm, T dot dist 2.70, and I lost it somewhere in my head here, 4, okay. And I believe it was 14 degrees of freedom. Let me double check again. Yep, 14 degrees of freedom. And then true. All right, now notice I get, and you can see where I did it a second ago, 0.991439. Now, what we have to take into account as we're doing a hypothesis test is what that alternate hypothesis is, okay? This is the area to the left of 2.704 on the normal curve. But let's notice that our alternate is a greater than, meaning we want the area to the right or the probability to the right. So we've got to take this value of 0.9914 and subtract it from 1. So if I subtract this from 1, I get 0.0086. That's my p-value. And typically p-values are going to be small. So realize that if you get like 0.99, you probably haven't done something yet. You need to subtract from 1. And if it's a two-tailed test, double it. But if it's a greater than, of course, you'll just subtract from 1. So really what you should have here is 0.0084.